In this video, we are solving CBSE 2021 physics question paper. Question paper code number is 05514. In the first question, an electric dipole placed in a non-uniform electric field will experience. So this is the dipole, minus q and plus q. They are separated by some distance, and this dipole is in non-uniform electric field. That means electric field at different places are different. So the force on minus q charge is minus q e1, and force on plus q charge is plus q e2. So the net force is equal to F1 plus F2 is equal to minus QE1 plus QE2, which is not equal to 0. So the net force is not 0. So this dipole in the non-uniform electric field experiences the force, and we also know that if this dipole is placed in electric field, then it experiences torque is equal to P cross E, where P is the dipole moment. P is equal to Q to A. So the option both force and torque will experience by this dipole. C option is the right option. In the second question, let N1 be the number of electric field lines going out on an imaginary cube of side A that enclose an isolated point charge plus 2q. So this is the cube. Inside this cube, 2q charge is placed, and N1 are the field lines, electric field lines going out from this cube, and N2 be the corresponding number for imaginary sphere of radius A that enclose an isolated point charge plus 3q, and there is an imaginary sphere, and these are N1, and the field lines from this sphere is N2. So we know number of field lines are related to flux. So let us write flux coming out from this 2q charge is equal to summation of q upon epsilon naught. So total charge enclosed by this cube, which is 2q by epsilon naught, and here phi 2 is equal to plus 3q by epsilon naught. So they are in the question, they are asking what is the ratio of N1 and N2. So we can write N1 by N2, that is related to phi 1 by phi 2 is equal to 2 by 3. So B is the right answer. In the third question, in a circuit given below, P is not equal to R and a reading of galvanometer is same with switch S is open or closed. So this is the diagram they gave. Battery having V potential plus minus. This side is P, this is R, this is Q, and here they connected a galvanometer, and here a key S. In the question they are saying that if S is open or closed, and one more condition they have given, P is not equal to R. The galvanometer is showing the same reading. So they are asking in which two sides the current will be same. So if S is open and S is closed, and in both the cases the galvanometer reading is same, that means no current is passing through this arm. So the current passing through this and this will be same, one option. The current passing through this and this will be same. So in the given option, from the given options, what I got is the current passing from R resistance is equal to the current passing through the galvanometer. So B option is the right option. In the fourth question, two wire A and B of the same material having length in the ratio 1:2, diameter in the ratio 2:3 are connected in series with a battery. The ratio of the potential difference VA and VB across the two wires respectively. Two wire A and B, the length is L1 is equal to L and L2 is equal to 2L. Diameter, which is equal to 2 of resistance, is equal to 2 D1 R1 and 2 into 2R, and D2 is equal to 2 R2 is equal to 2 into 3R. And these two wires are connected in series combination with a battery having voltage V. Then they are asking the ratio of potential difference VA and VB. So first we calculate the resistance of A wire. RA is equal to, in the question they mention that the same materials are using for both the wire. So RA is equal to rho L1 by pi R1 square. So rho L divided by pi 2R square. So this is 1 by 4 rho L by pi R square. Let us assume this as capital R, so R by 4. Similarly, RB is equal to rho L2 by pi R2 square. So rho 2L divided by pi 3R square is equal to 2 divided by 9 into R. So both the resistances R by 4 and 2R by 9 are connected in series combination. In series combination, the resistances simply add up. So the equivalent resistance R is equal to RA plus RB, which is R by 4 plus 2R by 9. So the total resistance is equal to 36 9R plus 8R is equal to 17 by 36R. So we can calculate the total current. I is equal to V by R, V by 17 into 36R. Now the potential drop across A and B, VA is equal to I into RA, which is 36R into V by 17 into R by 4. And VB is equal to I into RB. I is 36R V by 17. Sorry, V by R. V by R. Into 2R by 9. So from here 9 by 17 V. Here 8 by 17 V. So VA is to VB is 9 by 8. So D is the right option. In the fifth question, two moving coil galvanometer G1, G2 have the following particulars respectively. They mention the number N1 is equal to 30 number of turns, A1 is equal to 3.6 multiplied by 10 to the power minus 3 meter square, B1 is equal to 0.25 Tesla, and N2 is equal to 42 number of turns, area is equal to 1.8 into 10 to the power minus 3 meter square, and magnetic field B2 is equal to 0.5 Tesla. So the spring constant is same, that means K is same in both the cases. The ratio of current sensitivity G1 and G2. We know the formula of current sensitivity, G is equal to NBA divided by K. So G1 by G2 is equal to N1 B1 A1 divided by N2 B2 A2 is equal to 30 into 0.25 multiplied by 3.6 into 10 to the power minus 3 divided by 42.5 1.8 10 to the power minus 3 10 to the power minus 3 2 is equal to 5 by 7. So A option is the right option. In the sixth question, a current I is flowing through the loop as shown in the figure. Here they draw some. So I is current flowing from A, B, C and D, that is I, and the current is flowing from D to A is again I. The radius, the distance from here to here is R. The distance from M to C is 2R. So I current is flowing through the loop as shown in the diagram, and I mention MA is equal to R, MB is equal to 2R. The magnetic field at the center of the loop in terms of mu naught I divided by R. So the magnetic field at this point. So first we calculate the magnetic field due to this loop. I am doing the detailed calculation from the Biot-Savart rule. So first I am applying the Biot-Savart from A to D. So B is equal to dB is equal to mu naught upon 4 pi dl cross R divided by R cube. Mu naught upon 4 pi dl R divided by R cube. The angle between dl and R is 90 degree. So sin 90 is equal to 1. Here square. So from here if we want to write magnetic field B is equal to mu naught upon 4 pi R square and integration of dl. So for the first loop, small loop, B1 is equal to mu naught upon 4 pi by R square, and if we integrate dl, that means it is 3 by 2 pi r. The complete is 2r, so it is 3 by 2 part, 3 by 2 pi r, which is 3 2 pi r cancel out, 3 mu naught by 8 r. Similarly, B2 for the bigger loop, B2 is equal to mu naught upon 4 pi r square. This is just 1/4 part, so pi by 2 r is equal to mu naught 8 but the radius is again in the question they mentioned is 2r, so we have to write 2r here. So this is mu naught divided by 1 2 cancel out, 16r. So the magnetic field due to the smaller circle is 3 by 8 mu naught by r, and the bigger circle mu naught divided by 18r. So from the thumb rule, the magnetic field is due to this loop is inside, and from this loop also it is inside. So into the paper, so the direction of magnetic field is into the paper, and both are showing the same direction, so we can write the total magnetic field is equal to B1 plus B2 is equal to 3 by 8 mu naught r plus mu naught by 16r, which is, if we take the LCM, that is 16r, 6 plus 1 7 mu naught, so 7 mu naught divided by 16r. So D option is the right option. In the seventh question, a capacitor and an inductor are connected in two different AC circuit with a bulb glowing in each circuit. The bulb glow more brightly when so one capacitor and AC circuit, with this one bulb is there, one inductor, a bulb and AC source. In which condition the bulb glow more? We know AC circuit frequency is 50 Hz. Let us consider, so here also 50 Hz, and XC is equal to 1 upon omega C, and XL is equal to omega multiplied by L. If the potential drop across this capacitor is more, then the bulb get the less potential. Similarly, if the potential drop across L is more, then the bulb glow less. But in our condition, we want the bulb to glow more, so the potential drop across this inductance or in capacitance should be less, then only the bulb will glow more. Excuse me. So the number of turns, one can see that the XL, in the case of XL, the resistance will be more because the frequency is directly multiplying with the inductance. So we normally not consider the L case. We will go straightforward to the capacitor case. For the capacitor, two options are there. The separation between the plates of the capacitor is increased. So we know C is equal to epsilon naught A by D. If D, if we increase D, then capacitance decreases, and we know then potential will increase. So this option is again wrong. If a dielectric is introduced in a gap between the plates of the capacitance, if dielectric we will introduce, then the capacitance is equal to epsilon naught A divided by D times the dielectric constant. Then the capacitance increase, potential decrease. Yes, this is the situation where the bulb will glow more. So D option is the right option.